We've got Hooke's law, which says that the distance a spring stretches or compresses, we'll call that d. All right, d for that distance, from its natural or equilibrium length, varies directly. That tells us that we're working with the formula y equals kx as the applied force on the spring. We'll call that F. All right. Well, since we're working with y equals kx and we've got our distance and force, we've got distance, d, equals k times the force. Now we know that a force of 220 newtons, so we'll plug that in for k, for F, 220, stretches a spring 0.12 meters. And then we'd like to know what force stretches the spring 0.16 meters. So we can solve for k here by just dividing by 220. We get 0.12 over 220 equals k. Go ahead and type that into our calculator. 0.12 divided by 220. Okay. And we've got 0.0005454 just forever and ever and ever. Okay. I think maybe actually this would just be better if we leave this in a fraction form. So let's just actually leave it in the 0.12 because when we calculate later, we'll keep that. So we've got distance equals k times force. So this is our formula. And now we'd like to know what force stretches the spring 0.16 meters. So now we'll go ahead and plug that 0.16 in right here. 0.16 equals 0.12 over 220 times F. Okay, now to get rid of this, this fraction here with the F, let's go ahead and move it over just a little bit, and then we'll be able to multiply by the reciprocal of this, 220 over 0.12, okay, on both sides of the equation. And of course, we'll cancel it on the right side. And so we've got our 220 over 0.12 times 0.16, and that will be our force. Now let's go ahead and plug that into our calculator. So we've got 220 over 0.12 and then times 0.16. Okay, and we get 293.3. 293.3, and that 0.3 is probably repeating. We look at that, click up, hit enter. Yeah, we see it goes forever. So that's our force, and that's going to be, of course, in newtons.